Hello everyone, welcome to Simplilearn's YouTube channel. Today we will be discussing about Tower of Hanoi problem in programming. But before we begin, let me tell you guys that we have daily updates on multiple technologies. So if you are a tech geek in a continuous hunt for latest technological advancements, then consider getting subscribed to our YouTube channel and don't forget to hit that bell icon to never miss an update from Simplilearn. Now, without any further ado, let's get started with the agenda for today's discussion. We'll begin this discussion by understanding the Tower of Hanoi problem along with how we can construct a solution for it. Followed by that, we'll develop the C program which can solve this Tower of Hanoi problem. I hope I made myself clear with the agenda. Now let's get started with our first topic, which is understanding the Tower of Hanoi problem. The Tower of Hanoi is a mathematical puzzle made up of three towers and multiple rings arranged in ascending order of their diameters. The number of rods or tower is fixed, whereas the number of rings can be changed by the player. The setup of this game looks something like this. There are three towers in this diagram, and one of the tower is decked with several number of discs or rings, such that the largest disc is at the bottom and the smallest disc is at the top. A player's goal is to move these discs one at a time to a particular destination tower in the same specific configuration at the start. That means the order of discs should not be changed after being transferred to the destination tower. Before you get ahead of yourself and deem this problem to be trivial, there is one crucial aspect to consider. In this problem, you are not allowed to transfer a larger disk on the top of a smaller disk at any stage. This rule makes solving this problem substantially difficult. However, this problem can be solved using the auxiliary tower or helper tower. By altering the position of disk using three towers, we can take all the disks present at source tower to the destination tower. This is quite confusing, right? So, to make this understandable to all of you, let me give you a rough example. In this Tower of Hanoi problem, we have three rings at the source tower. Now to attain the same sequence at the destination tower, we'll move the top two rings to the helper tower. After that, we can move a ring with highest diameter to the destination tower. Now, if we just move the two rings present at the helper tower to the destination tower, we'll solve our problem. But let me tell you guys that this explanation was just to make you visualize this problem more straightforward manner. In reality, this problem becomes more complex when the rules for the movement of rings are applied. So moving forward, let's look at those rules for ring movement in the Tower of Hanoi problem. The first rule that we have is at any instance only one disk can be moved from the tower. That means we cannot move more than one disk at a time. The next rule on our list conveys that a disk can only be moved if it is the uppermost disk of the stack. The last and essential rule is no disk should be placed on the top of another disk that is smaller in size. So let's look at another Tower of Hanoi problem to build solution using these set of rules. In this problem, we have four disks to increase our problem's complexity, whereas the number of towers remain the same. In order to formulate the solution, we are allowed to move these rings into different towers. So the first move we are supposed to do is moving the orange disk to the helper tower. Next, we can move green disk to the destination tower, and after that, we can move the orange disk to the destination tower. We'll place this orange disk over the green disk. Now, our helper tower is empty. So let's take out our yellow ring from the source tower to the helper tower. Now, we'll move the orange ring to the source tower. Further, we'll move green ring to the helper tower. This movement will make our destination tower empty so that we can bring this larger disk to it. Next, we'll move orange ring to the helper tower. This move will make room for the transfer of largest disk to the destination tower. Now, we have brought our largest disk to the destination tower. However, we still need to bring 3 more disks to our destination tower in order to solve this TOH problem. And to do that, here we'll move orange ring to the destination tower and the green ring to the source tower. After that, we'll move orange ring to the source tower in order to bring the second largest ring to our destination tower. Here, we have successfully placed 2 rings at the destination tower. Now, we only left with arrangement of 2 more rings. To attain that, here we'll move orange ring to the helper tower and green ring to the destination tower. Finally, we'll move orange ring to the destination tower. And this is how we'll land at accurate solution to our Tower of Hanoi problem. If you observe this process, you'll get that the process of ring movement is of recursive nature, and we can develop a solution to this problem using recursive programming paradigm. So moving ahead, we'll develop a program to implement a solution to this Tower of Hanoi problem. The language that we are going to use for this implementation is C programming language. So without wasting any time, let's move to the code editor. Here, to begin with our Tower of Hanoi implementation, let's first create an utility function named TOH. So we'll do that, void TOH, and inside this function we'll pass few arguments. The first argument we'll pass to this function will be the number of rings in our TOH problem. So let's call that variable n, and the subsequent arguments will be the source tower, destination tower and helper tower. All these 3 arguments will be of character data type as we want to pass the names of towers here. So we'll create char source, next char destination and char helper tower. Next, now inside this function body, we'll make recursive call to the same function in order to move the disk. Inside this recursive call, we'll tell our IDE to move n-1 disk from source tower to the helper tower. And to do that, the statement that we'll write is TOH move n-1 disk, that is this n. Next will be the source, then helper underscore t, which will act as destination here, and destination tower will act as an helper tower. So basically this call is nothing but these arguments over here. This recursive call will allow n-1 rings to move from source tower to the helper tower by taking the help of destination tower. So by using this statement, we have moved n-1 rings from source to the helper tower. Next, what we'll do is we want to print all these movements covered by this function. Hence, let's create a format for printing the disk movement using printf function. The format that we'll use is printf, add /n, next move disk modulus d from tower modulus c to tower modulus c. And after this, by taking comma, we'll pass arguments. The first will be modulus d, that is number of tower. Next will be the source, and after that it will be destination. So by moving n-1 disk to the helper tower, we have made space for moving the largest disk to the destination tower. And next, we'll have to move these n-1 rings to the destination tower from the helper tower by using the source node. So for that, we'll write another recursive call, TOH n-1 helper underscore t will act as source now, and destination will act as destination, whereas source will act as helper tower. Now, what will be the base case for this recursive function? Well, it's pretty easy. The recursive call we are making is actually decreasing the disk number, that is n minus 1, and thus after few iterations the value of n will become 0. And when it reaches 0, we want to stop our recursion. So our base condition will be if n becomes equal to 0, we will return the control to the next function. So with this, we have successfully created our tower of Hanoi function. Next, we'll move to our driver method, that is main method, in order to contemplate the TOH function. So what we'll do is we'll pass arguments to TOH function. The number of rings that we are going to use for this problem will be 4. And let's call our towers as A, then B, and C, and return 0. Now let's check if our code works fine or not. Okay, so we are getting one error over here, semicolon missing. Okay, so let's add that semicolon and rerun our code. Okay, so we have received output here. The output is 15 steps that we have discussed earlier for the 4 rings TOH problem. And that output is what we have received here. That means our program works accurately. You can verify this output by matching these movements with the previous solution that we have discussed earlier. The only thing to note here is that the tower B is acting as destination, tower A is acting as source, and tower C is acting as helper tower. I hope you guys are clear with Tower of Hanoi implementation now. This is all about Tower of Hanoi implementation using C programming language. I hope the implementation strategy covered in this video is clear to all of you out there. If you have any queries regarding the concept covered in this video, then let us know about it in comment section below and we'll surely get back to you. Thank you so much for being here and do watch out for more videos from Simplilearn. Until then, keep learning and stay tuned to Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.